planets around other stars. We didn't know they existed until very recently. Now we count far more of them than planets in our own solar system. These worlds are stranger than anyone imagined, and their solar systems can be more violent than we ever knew. The pace of discovery is increasing, driven by the prospect that some of these alien planets may be havens for life. Ever since human beings first gazed at the night sky, we've wondered, are we alone? Who or what is out there? On which planets or moons might they live? For millennia, these questions have fascinated dreamers and philosophers. They're now the business of astronomers, who are just starting to discover new worlds, alien planets around distant stars. Finding new planets has been one of the great challenges of astronomy. We can see the planets of our own solar system through a telescope, but a planet around a distant star would be too small, too faint to see directly with an ordinary telescope. An alien world would be invisible in the glare of the star it orbits. So planet hunters must study what they can see, stars, and look for the subtle signature of an unseen planet. At the Lick Observatory near San Jose, California, the quest for alien planets is now in high gear. For astronomer Deborah Fisher, the search for a planet of her own is a labor of love.
I love the telescope. I love the way the dome smells, the electronics smell. I love the sound of the motors going and whirring. I love the computers working. It's all magical, and it hasn't lost a bit of its excitement for me.
Fisher will study a number of stars, viewing each one again and again over years to look for telltale changes in light, changes that might prove the star has a companion, a planet. She drives her team to make the most of each night as they race against dawn. On a perfect evening, she'll aim the telescope at 100 stars.
Star will be Tau Ceti.
Tau Ceti?
Yeah, it's kind of a feeling of power to know that I'm telling the telescope, directing the telescope to point at a particular spot so that I can learn something, sort of spy on that star and learn something new about it.
When she sees the speed of a star change with a clear rhythm, she'll know the star has an orbiting planet. Just as two rollerbladers spin around each other, a planet and its star are in mutual orbit. Gravity works in both directions, so that even a small object like a planet will cause a much larger object like a star to wobble. Such a wobble in a distant star would be indirect evidence of a planet. But how do you see the wobble of a star? Just as sound rises in pitch as its source travels toward us, and drops as it moves away, so light shifts in color as a star wobbles. For years, Fisher and her collaborators have been looking at a star called Gliese 876. The star's color has been shifting. Fisher is hopeful she's seeing a wobble caused by a planet, but she isn't yet convinced. Fisher isn't the only researcher to look for rhythmic star motion. In 1994, another team was searching the constellation Pegasus. Back then, no one had ever found a planet around a distant shining star. Astronomer Didier Queloz thought he saw a star wobbling because of a planet. If Collot was wrong, his credibility and his young career might be destroyed.
I realized that it was highly risky if the data turned out to be wrong or a mistake. It would have been very bad for me.
The technical challenges were reason enough for caution. Earth zooms through space, but stars move slowly.
It's as if you were in a rocket and trying to monitor the speed of ant on the ground.
Collot had to figure out what his measurements meant. He first convinced himself he wasn't seeing sunspots on his star, called 51 Peg, rather than star motion. He next made sure the star wasn't quivering like a serving of cosmic jello, rather than moving back and forth. Finally, Collot knew what 51 Peg wasn't. Now he had to take the leap to say what it was. Didier Collot's star was wobbling. After careful study, only one explanation made sense. An unseen planet must be moving 51 Peg. Collot had discovered the first planet orbiting a distant shining star, but others were skeptical.
When we announced 51 Peg, I think that maybe only 10% of people believe we had a planet.
Scientists never thought such a world could exist. It was a planet 140 times the mass of Earth, and it wasn't supposed to orbit this close to its star, according to planetary theory. Collot's world is an unlikely site for life. It whips around 51 Peg every 4 days. The temperature is 1,500 degrees Fahrenheit, so hot that the metal nickel vaporizes, perhaps adding a blue glow to the fiery atmosphere. After Didier Collot's discovery, other planet hunters knew they were on the right track. Now more than ever, Deborah Fisher and co-workers were eager to find their own world. If her star is really wobbling because of a planet, she should be able to predict the star's next move. Fisher began with the star speeds she had measured. She then used these measurements to make predictions of what her star would do next. As she observed her star again on a series of nights, each of her predictions came true. Deborah Fisher had found her first planet.
It was a very powerful feeling to make a prediction and have the star obey my command.
Fisher's planet is a ball of gas nearly 700 times the mass of Earth. Her planet swings in a wild orbit that takes it from burning proximity to the star to a freezing distance.
These planets almost certainly have moons around them. On those moons, there could certainly be places that we would consider, very hospitable places for life to form.
The very idea of alien life on alien worlds was once incendiary. In the year 1600, at the Field of Flowers in Rome, a pyre was prepared for a heretic. His name was Giordano Bruno. A philosopher and former monk, Bruno lived only a few years before telescopes were invented. Yet Bruno was convinced that every star had planets, and every planet teemed with life. Didier Collot was risking his career if he had been incorrect, but Bruno, whether right or wrong, had risked his very life. Imprisoned for 8 years by the Inquisition, he had been begged to recant. On this day, there would be no such offer. Other worlds, a disturbing idea, an idea that must be suppressed. Wasn't Earth a unique creation? Would each of Bruno's worlds have its own Jesus? Pull on one thread of Bruno's thinking, and all of Catholicism seemed to unravel. His writings were declared erroneous, his volumes ordered burned and placed on the index of forbidden books. But Bruno remained defiant. Most criminals were strangled first and later burned in effigy. But Bruno's heresies were so corrosive that he was sentenced to die by flame. The man who dared to say that Earth was not the only world God created now paid the terrible price of his convictions. Bruno was aware of the oddballs in the sky, the wandering lights we call planets. But he never imagined that one day we would see them clearly and send probes to measure and even touch them. Bruno guessed that the universe held not one world, our own, or 1,000, but an infinity of worlds. We still don't know how many planets exist, but as we discover more and more of them, we can't help wonder if they might harbor life. Could we even recognize life if we saw it?
We have a go for main engine start. 6, 5, 4, 3, 2, 1. And liftoff.
Launched in 1988, the spacecraft Galileo would search for signs of life. In 1990, Galileo approached a planet. The spacecraft's instruments scanned the surface. Researchers were amazed. Galileo had detected intriguing chemical signatures. Carbon dioxide, methane, oxygen. Radio waves from the planet's surface were also picked up. Only one interpretation made sense. Life had been detected. The Galileo spacecraft's report of a living world thrilled scientists. Finding alien creatures would change our view of the universe. But Galileo had not scored the biggest scoop in history. The planet Galileo was examining was Earth. But this small spacecraft proved that at least we have the ability to detect life on other worlds. Galileo then left Earth behind to head for Jupiter. Passing Jupiter's volcanic moon, Io, Galileo targeted another moon, Europa. Europa fascinates planet hunters like Deborah Fisher, because many of the new worlds she's discovered may have similar moons. Strangely, Europa has the best prospects for life in our solar system. At first glance, Europa looks too hostile for life. Its surface is 260 degrees below 0 Fahrenheit. Galileo revealed in fresh detail a world frozen over with water ice, crisscrossed with cracks from Jupiter's huge gravitational pull. The surface is sprinkled with frozen sulfuric acid. So where could life possibly exist? Europa's ice may float on a vast ocean of liquid water. The spacecraft Europa Orbiter will be launched in 2003 to seek evidence of liquid water. If confirmed, Europa's water will be the first extraterrestrial ocean ever discovered. If Europa has an ocean, then so might a moon around Deborah Fisher's planet. In Death Valley, California, the ground reaches temperatures of 190 degrees Fahrenheit. The surface is sterile, caked with toxic salts. Two scientists are looking here for scrappy forms of life. If something can survive here, it may be a model of what to look for on alien worlds that are harsh and dry.
Yeah.
Get to the center of them.
Ken Nielsen is a researcher at the Jet Propulsion Laboratory.
Layer, doesn't it?
Pamela Conrad is a scientist in Nielsen's group.
Back there.
Conrad and Nielsen were trained to think that life was fragile, that life required exacting conditions. But their exploration of Earth's extremes is convincing them that life is far tougher than we ever imagined. Even in this hell on Earth, if you just scratch the surface, life will show its true colors. The desert is anything but dead. Just under the crust is a layer of green algae. Below is a layer of red bacteria. At the bottom of this Death Valley layer cake is black sulfur-eating bacteria.
This is what we call a layered microbial community, and it's probably the major form in life on this planet for the first 2 billion years of the planet's history. 20 years ago, if we would have been told that organisms live the way we know they live now, we would have denied it. These are truly extreme organisms that change the way we think about how to look for life in the universe.
The discovery of life's toughness on Earth is fascinating news for planet seekers like Deborah Fisher, whose new worlds are likely to be harsh realms. But how would we find life on another world? Some scientists say they've already seen it in a small piece of Mars. On June 28, 1911, 20 pounds of rock crashed from space into northern Egypt. It was a divot hacked out of Mars by a meteorite impact. Some researchers see the rounded structures in this microscopic view as mineralized bacteria. Others say the bumps are too small to have been alive.
Got your rolling action.
Nielsen hopes to get his hands on more definitive evidence about life on Mars. He's preparing by looking for the signature of life in Earth rocks.
And that actually does look like there's some stuff down underneath there. Mm-hmm. There.
It's a new kind of quest.
No one ever gives you a rock and said, is the Earth alive? They give you a frog and say, how does it work? Or give you some DNA and ask what the sequence is. But no one ever gives you a rock and says, is the planet alive?
Nielsen will soon be given his Martian rock. A rover like this will soon gather rock samples on Mars and, with luck, return them to Earth.
We'll have samples that we know where they came from, and we personally collected them. They will be pristine samples, not having sat on the surface of the Earth.
NASA's Mars Sample Return mission will land a vehicle on the Red Planet in 2005. The rover will pick up promising samples. samples will be sealed and launched to a spacecraft in Martian orbit. In 2008, scientists like Nielsen and Conrad will get a close-up look of carefully chosen rocks from a neighboring world. It will be one small sample that may answer one big question. Was there ever life on Mars? Every planet hunter can't wait to hear the answer. Because if we find life on Mars, prospects for life on new alien planets suddenly become brighter. But the very idea of life on Mars was recently considered impossible. The Viking missions of the 70s landed on Mars and pronounced it dead on arrival. Mars today is a world without a drop of liquid water on its surface. Winters are so cold that 1/4 of the thin atmosphere freezes solid and drops out of the sky. But Mars was not always arid. It once had water in abundance. The 1997 Pathfinder mission added to the evidence for ancient Martian floods. Pathfinder bounced to a safe landing on Mars like a spacewalking Michelin man. Touching down at what appears to be the debris tail of a flood that occurred over 2 billion years ago. The twin peaks, the two hills on the horizon, are streamlined as if by flowing water. If Mars once had water, could it once have had life?
It's believed that Earth and Mars were quite similar in their early stages for the first 500 million years. And that's the time that life evolved on Earth. So one can't really argue that life didn't evolve on Mars. It's as likely that it did as not.
We used to think life needed to be coddled, that it required just the right conditions. But now it seems that life is almost impossible to defeat. It's a shift in perspective that Giordano Bruno would have cheered. Search for alien life is gaining momentum at the University of Arizona. Under the football stadium is one of the world's leading labs for making telescope mirrors. After it's polished and given a reflective coating, this piece of glass will be used in a telescope not only to find alien worlds, but to analyze what they're made of and look for chemical signs of life. Roger Angel is co-director of the lab.
This is the biggest piece of glass in the world, not only the biggest mirror. So we were thinking how we would get this to the mountaintop. And this pretty much closes down the I-10 freeway when we move this out of Tucson. The European one is 8.2 meter. Then the Japanese came along and said, well, ours is going to be 8.3. And then at that time, we had to finalize our size, so we decided on 8.4, which is the biggest.
So size does matter?
Size does matter.
Angel's workers don't fear to tread on this mirror that will be polished within 10 molecules of perfect thickness.
We'll be able to see things with more detail than any other telescope. And in fact, we think we're going to get 10 times the sharpness of the Hubble telescope, which is pretty extraordinary.
As the mirror is being completed, the observatory that will use it is being constructed just over 100 miles away on Mount Graham. construction may look ordinary. This observatory aims to achieve the extraordinary, the first glimpse of chemical compounds on alien worlds. Perhaps the first clue of alien life. On the balcony where the lid of the glass melting oven is stored, Angel consults with a colleague about the next step for his new telescope.
Coming along pretty good.
Down below, preparations are being made for the most radical feature of Angel's big mirror.
Oh yeah, this looks terrific.
It will have an identical twin. A mold is being constructed for the second mirror. It will soon be ready to receive the raw ingredients. Angel's novel two-eyed telescope may be the first to analyze directly the faint light of an alien planet. The two mirrors will be yoked together to create history's biggest pair of binoculars. Each mirror will have a slightly different view of a star. The light waves from these two vantage points will be combined to reveal a distant planet's light.
Well, the difficulty with trying to see planets around stars is that they can be 1 million or even 1 billion times fainter than the star. So any kind of glare from the star spoils your view of the planet. There's a trick to get rid of the starlight and leave the planet light there. And what you can do is combine the waves from the two mirrors so that the crests from the wave from one mirror come at the same time as the troughs from the other. When you add those together, the starlight cancels. So in that way, you can make the star thousands or tens of thousands of times fainter and leave the planet so you can detect it.
To reach the cutting edge of planet finding, Angel's telescope needs one extra trick beyond having two eyes. All Earth-bound telescopes see stars twinkle, a distortion caused by peering through air of different temperatures. Angel will untwinkle the stars. He'll do it with small mirrors in the telescope that change shape 1,000 times a second. Here's what a star looks like through the atmosphere. And now the bendable mirror kicks in, sharpening the image almost to a point. If Angel's binocular telescope works as planned, he'll be able to analyze the light from alien worlds to get the first ever information about their chemistry and possible signs of life. The science of other worlds is entering a new stage.
What's exciting to me is now we can take this beyond speculation. We can go measure.
What's driving Angel is the new prospect of a real answer, hard evidence for life on other worlds. What allows life to exist on Earth? A big factor is that our solar system today is peaceful and orderly. Our planets don't crash into each other or the sun. The Earth and its neighboring planets face the same steady conditions over eons, giving life plenty of time to evolve. But the alien worlds we're discovering are very different. They may belong to solar systems that are as violent as a game of cosmic billiards. Astrophysicist Doug Lynn thinks the typical solar system could be a dangerous place where worlds collide. Huge planets may roam wildly. Life would be impossible in such an unstable solar system. Our own solar system may once have been chaotic. In fact, our own Jupiter may be the lone survivor of a violent lineage of Jupiters.
It is entirely possible that most of these Jupiters have crashed into the sun. And what we are seeing today with Jupiter and Saturn, they are the last of the Mohicans.
Doug Lynn knows that planets migrate because alien worlds orbit close to their stars, where it's too hot for them to have formed. In a young solar system, a big planet like Jupiter may tug on nearby gas and dust, and so lose energy. It will cross other planets' orbits as it spirals toward its star. A small Earth-like planet in its path will be destroyed in one of two ways. It may be whipped out of the solar system, or the larger planet's gravity may send it on a death plunge into the star. Small planets like Earth are also threatened by asteroids and comets. And strangely, a dangerous planet like Jupiter can now play the role of protector. In 1994, Jupiter performed its role of cosmic outfielder by capturing comet Shoemaker-Levy and breaking it into a score of fragments. Then Jupiter caught the pieces one by one, like pop flies. Each fragment struck Jupiter with a force of 25 billion tons of TNT. Any one of these impacts would have caused a cataclysm on Earth. Jupiters can't live with them, can't live without them. A small planet might need a huge world for protection. The new alien planets are telling us that our own solar system may be unusually calm. Many new worlds careen in wild orbits. Others have spiraled in toward their stars. Many may have blasted smaller planets to smithereens. If we're discovering the violent lives of planetary systems, we're also finding out that their births can be just as extreme. Scientists have a good idea how planets are made. All you need is a blob of dust and gas. Gravity does the rest, pulling the material together in a flat, spinning disk. The star forms from the bulge at the center. Planets coalesce farther out. It makes perfect sense that the planets of a solar system lie in a plane and orbit in the same direction. Recent images revealed a surprising, violent phase in developing solar systems. An era when huge jets of blazing gas roar away from each stellar pole. But a later stage in solar system life surprised even the astronomer who discovered it.
I still remember vividly when we were looking around this particular star. We changed the camera and suddenly there it was. We were extremely excited. I ran into the kitchen, got all my collaborators. We all stood around and kind of yelled for a while. The exciting thing about it was we had seen a disk in which there was a large hole.
The hole could only have been swept out and maintained by an unseen planet. Not only had Kerner seen the birth of a solar system, he had found a new kind of evidence for alien worlds.
The disks actually give indirect signatures of planets themselves, much like the stars that are wobbling under the influence of planets do.
Even if all solar systems form in similar ways, the new worlds we've detected excel in variety. For Kerner, this is the biggest surprise.
This is what we're discovering, the context of our own solar system within a huge diversity of extrasolar planetary systems.
At the Lick Observatory, Bill Barucki is trying out a new method for finding planets.
Okay, that should do it.
Okay. Take a look at that filter. I think it had some spots on it that needed cleaning.
Well, if you've got another filter, that would be great.
Yeah, we got
a planet that passes between its star and Earth blocks some of the star's light.
Okay, get the left-handed one this time.
The star will seem to get dimmer for a few hours and then brighten up again.
Good. The method we're using is really very straightforward to understand. Even Bruno, many hundreds of years ago, could have understood it and probably would have appreciated it.
Barucki will look for miniature eclipses of distant stars. A star will dim as its planet crosses in front of it. Only 1 in 10 planetary systems will be angled so that starlight is blocked. So Barucki must cast a big net. He will monitor the brightness of 4,000 stars night after night.
There we go.
The bigger the planet, the more starlight will dim.
Looks pretty good.
Okay.
Baruchi's method will be the first to reveal the size of an alien world.
Go over the operating room here if I don't fall off.
It's a perfect complement to the method of Deborah Fisher and her team.
They get the mass of the planet. Our method gives us the size of the planet. If you put the two methods together, we get density.
Yeah, I'll change the...
We can tell whether the planet is a gas giant like Jupiter or is a hot rock.
After 2 years of searching, Baruchi finally proved his method worked. A star's light dimmed and brightened in a regular pattern as a distant planet orbited. A couple of hundred yards away at the Lick Observatory, Deborah Fisher prepares for her next night of planet hunting. Light from the telescope caroms down into this basement room. Fisher adjusts equipment to make sure her star speed measurements are as precise as possible. She has a number of planetary discoveries under her belt, but now she's looking for something bigger. She wants to find not just another planet, but a solar system. Only one alien solar system is known. Found in 1991, it's one of the strangest objects in the heavens. A radio telescope had been listening to intriguing signals. The signals told of the death of 2 stars and the birth of 3 planets. Long ago, 2 small stars orbiting each other merged to cause a supernova. The blast created a pulsar, the fast-spinning remains of a star. 3 planets were born from the ashes of the explosion. This is the first solar system ever discovered beyond our own. If the pulsar's beam, a death ray, strikes the planets, they'd be as warm as Earth, but as hospitable to life as Chernobyl's core. The pulsar planets are dead worlds orbiting a dead star. But Fisher has her eye on a shining star with a wobble that can't be caused by the tug of a single planet. Fisher has found a new solar system around a star called Upsilon Andromedae.
There's a moment when you're finally satisfied, what I've done is nice and it fits and everything looks right. And then in 5 minutes go to a staggering, surprising feeling of what the implications of this are.
Fisher and her team have made a major discovery, the first planetary system around a shining star. The inner planet orbits so close to the star it may trigger titanic stellar eruptions. The planet may show a constant face to its star, creating a seething atmosphere that may hold aloft clouds of ice. The middle world may have moons as large as Mars, some with atmospheres of their own. The outer world might have huge moons full of ice. Worlds reminiscent of Jupiter's Europa. Fisher's new solar system around Upsilon Andromedae seems to prove that everywhere there can be planets, there are planets. None of the new worlds found so far is as small as Earth. Detecting a planet is easier when it's big enough to cause a huge wobble in its star, like the 30-mile-an-hour motion of our own sun caused by Jupiter's gravity. We may eventually measure wobbles under 3 miles an hour, the signature of a mid-sized planet like Saturn tugging its star. But can we find a wobble caused by a small planet the size of Earth, which moves the sun at 1/5 of a mile an hour? It's unlikely star speed will ever be clocked so precisely because a star's surface roils confusing fine measurements. Scheduled for launch in 2011, Terrestrial Planet Finder will be an orbiting telescope made of mirrors flying in tight formation. The mirror's light will be combined to cancel the glare of distant stars as never before. And with any luck, we'll get our first detailed image of an Earth-like planet, a sister, a cousin. However it appears, the discovery will begin a new epoch. We will feel less unique. We will also feel less alone. We will have taken another giant leap toward the complete vindication of a heretic. Giordano Bruno wrote, "The countless worlds in the universe are no worse and no less inhabited than our Earth. Destroy the theories that the Earth is the center of the universe." 4 centuries later, it's hard to imagine how dangerous his ideas once seemed.
Everything that we're finding tells us that every star that's like our sun has a host of planets around it. I know that there are 200 billion stars in our Milky Way galaxy, and there are billions of chances for life, for evolution, to get a toehold on one of these planets. So it changes my perspective of our place as humanity, our role in the universe.
A new generation of planet finders in a brief span of time has detected more worlds that circle other stars than orbit our own sun. We once thought that our own solar system might be unique. Now we know that solar systems are probably as common as stars. The alien worlds we found show that the typical solar system is born in violence and then has a hard time settling down. The word planet originally meant wanderer, and we're discovering that far-off worlds have wandered more than we ever imagined possible. We've discovered that giant planets control the fate of smaller worlds, at times protecting them, at other times destroying them. Our new alien planets make up a wild menagerie beyond the dreams of science fiction. Some planets may be covered with an ocean of liquid rock into which sulfuric acid rains. Other worlds, ejected from their solar systems, may wander like orphans through the dark and freezing spaces of our galaxy. Still, other planets are so hot that when it rains, it's not water but sand that pours down from the sky. Yet other worlds of Neptune's size may forge diamonds in their atmospheres, which then plummet onto a solid diamond core. The new alien planets, for all their strangeness, may be no strangers to life. For our own planet has shown us that life can thrive in the most extreme places we've explored. Giordano Bruno died for insisting that worlds orbit other stars. The terrible irony is that he felt his ideas only added to the Creator's eminence. Bruno wrote, "God is glorified not in one, but in countless suns, not in a single earth, a single world, but in 1,000,000, I say, in an infinity of worlds." Thousands, millions, however many may exist, the worlds of our universe now beckon us to find them, to study, and celebrate their splendors.